Welcome back, everyone. In this lecture, we're going to be discussing object-oriented programming again, and particularly, we'll talk about class object attributes. And these are attributes that are going to be the same for any instance of the class, and then we'll move on to discussing methods, which are basically actions that you perform with the object you created. Let's jump back to the Jupyter Notebook where we left off last time. Okay, so here we can see our dog class that we created last time. And we also saw how the user could define various attributes. They could define the breed of the dog, such as Lab or Husky or Golden Retriever. They could define the name of the dog, Sammy, Frankie, whatever you happen to call your dog. And then we can define some sort of Boolean variable or even a string, whether or not it has spots. And here we saw we passed in the parameter as the user, and then it got assigned to the attribute over here. Now there may be attributes that are going to be the same for any instance of the dog class. For example, we know that it doesn't matter whether a dog has a certain breed, a certain name, whether or not it has spots, it's always going to be a mammal. So something we may want to do is have an attribute be defined at a class object level. Instead of having the particular instance always say that the dog is a mammal, instead we'll define an attribute above our init method here. So above this special method at the very start, we can define what's known as a class object attribute. And these are the same for any instance of a class. So let's go ahead and define a class object attribute. And what's special about these, since we know it's going to be the same for any instance of a class, we don't use the self keyword, because we know that the self keyword is a reference to this particular instance of a class. But since the class object attribute is the same for any instance of a class, we can just say something like the species attribute is equal to mammal. Now, as a quick note, if you're familiar with biological scientific classification, technically species is the wrong word to use here. It goes kingdom, phylum, and then later on class, and class is actually where mammal falls, but I don't want to end up accidentally using the class keyword twice here. So instead, we'll just pretend that the species of a dog is a mammal. Okay, so that's a side note for biology, but basically what we have here, back to Python, the class object attribute is going to be the same for any instance of a class. So let's test out this theory. I'm going to add this class object attribute. Again, note how I'm not using the self keyword because it's going to be true regardless of the instance. I rerun that cell, and if I call dog again and do shift tab, I still only need to define breed, name, and spots. So let's say the breed is again a lab. We'll say the name, the name is equal to Sam, and spots, we'll say false, Sammy doesn't have spots. So I rerun this, now I have my dog ready to go. It's still a dog, and if I look at .tab here, I can see breed, name, and species. So species, even though we didn't define it, it's always available to us, and this is going to be the same, mammal, regardless of the instance of my dog. So it doesn't matter what I pass in for breed, name, or spots, because this attribute is not connected to self, it's not connected to any particular instance, so it's a class object attribute. And the way we format it is we have the class keyword, the name of the class, and then any class object attributes, and then you have your special init method for user-defined attributes. Okay, so those are the basics of attributes, mainly from the previous lecture for user-defined attributes, and then we have class object attributes. What I want to do now is actually discuss methods. Methods are essentially functions defined inside the body of the class, and they're used to perform operations that sometimes utilize the actual attributes of the object we created. So you can basically think of methods as functions acting on an object that take the object itself into account through the use of the self argument or self keyword. So what we'll do here is create our first method. So again, methods, unlike attributes, are more like actions. So these are operations / actions, and we can think of these formally as methods. And they basically look like functions inside of a class. And a lot of times beginners ask me, hey, what's the difference between a function and a method? Basically, a method is a function that is inside of a class that will actually work with the object in some way. So let's define DEF, and let's define an action for this dog to take. For example, maybe our dog could bark. And what we're going to do is say self, that way we connect this to the actual object so the dog can bark. And what's going to happen is when you call .bark, on the actual dog instance, it's going to print something. And let's have it print woof. And let's go ahead and delete the name. Well, let's delete the spots attribute, so we're not dealing with so many attributes here. I'll delete spots here as well, and I'm going to rerun this. So we'll rerun this cell, and now if we take a look at my dog, Shift Tab here, it only needs the breed and the name. So let's define a breed for this dog again. We're going to say lab. Notice now I'm not bother passing the actual argument name there and just putting them in order. And then the next one was the name of the dog. So we'll have the name of the dog be Frankie. So I rerun this, and now I have my Frankie, which is a lab here, and the type is dog. And if we take a look at the species, it's still a mammal, and now the name of the dog is Frankie. So one of the key differences between attributes and methods is in the way we call them. Notice that attributes never had open and closed parentheses, and that's because attributes aren't really something that you execute. Instead, it's just something that's a characteristic of the object that you call back. So it's just information there about the actual dog. And I'm going to zoom out one level so we can see everything together here. So as I mentioned, for the attributes themselves, there's nothing to actually execute. Now for methods, that's a little different. And in fact, methods will need to be executed. So that means we need to have the open and closed parentheses when we do a method call. And I'll show you why. So right now I have my dog, and my dog is a mammal, it's a lab, and it's Frankie, and I want my dog to bark. If I just call bark right now with no open closed parentheses, you'll get back something that looks like this. And this basically says, hey, you have this method that's bound to your object, dog, at this location at your computer's memory. If you actually want to execute the bark method, you have open and close parentheses, you run that, and then you get back whatever the actual method does. In this case, it's just printing out woof. So that's how a method works. It's basically just an action that the actual object can take. In this case, it didn't really do anything besides the print statement, but usually methods are going to use information about the object itself. And we know that information about a particular instance of the object could be something like the name. So let's have the dog bark its own name. In this case, we'll say wolf, and here we're going to say my name is, and we'll use dot format here to pass in the actual dog's name. Now, a really common mistake that people do when they're first learning about object-oriented programming is they just pass in name. However, when we're working with objects, that's actually not good enough. What we need to do is reference the particular instance of the dog's name, meaning we need to reference not name, but self.name. Because when you pass in name at the beginning, it gets connected to the object through the use of this self keyword. So here we need to say self.name. And that's going to, when you run bark, it's going to say print woof, my name is, and it's going to say, hey, what is this dog's name? For this particular instance of the dog object, find its name. And it does that through the self.name call. And then we'll just insert it automatically because we only have one curly brace there. So we run that, and we're using print formatting there, which you can always review in case you're unfamiliar with this format call. Again, we'll say lab Frankie, rerun all of this to make sure that the bark operation has been set. And now, when we call bark, it's going to say woof, my name is Frankie. So it's able to actually reference things in the attribute sector. So you're able to say self.name and pass that in successfully into bark. Notice here how we call the self automatically. That way, in case we ever need to reference things, it knows what instance of the object it's talking about. Now, methods can take outside arguments, so we can pass it some other argument here. So we could say pass in some number. So what we could do here is when you call bark, you need to pass in some number. So we'll say woof, my name is blank, and the number is, and we'll say comma number. So note the difference here. I'm no longer saying self.number because number is already being provided for us when we actually call bark. So that means we need to actually pass in a number call. So I'm going to again rerun everything to make the changes to bark here. Rerun lab Frankie, rerun this, rerun that. And now my dog, if I hit tab here, it has bark, breed, name, and species. So what we're going to do is call bark And if I just call bark like this, so let me zoom in very quickly. Let me delete the old line here. So if I just call bark like this, I'm now going to get an error. It's going to say, hey, bark's missing one required positional argument, number. So now this method is expecting some sort of added argument, number, because when this dog barks, it's going to say its name and the number you passed, because I'm passing it in here with number. Again, note here now I'm not using self.number because the user is provided that. It's not referencing some particular attribute for that instance of the class, like the breed or the name. So let's give it a number to bark for us. We'll say 10. Run that, and then it says, woof, my name is Frankie, and the number is 10. And those are the basics of using a method for a class. You say def, the name of your method. Notice now we're using lowercase, so it follows the conventions of a normal function call, except it's inside of a class. And then you pass in always the self keyword, and then you can work with other attributes by referencing them in a self.manner, or you can pass in new arguments that the user provides and reference those as well, no longer needing the self call because it's not connected to a particular instance of the class. It's just something that the user provides for you when they make the call. Okay, so we went over methods right now. I'm going to start a new class just to really drive the point home. So make a couple of new cells here, and I'm going to create a class called circle. So my circle class, let's give it a class object attribute. And remember, a class object attribute is something that should be true when you have any instance of the class. So for example, I know that pi is going to be equal to, more or less, 3.14, no matter how big a circle is. So I will set that as a class object attribute. So regardless of the instance of a circle I make, I will always be able to reference pi up here as 3.14. So now we create our init method. This is a special method. We always pass in self. So it's very common to forget that when you're first starting to work with objects, but you always pass in self. And now whatever we need to define a circle. So an argument we may need to define a circle is a radius. And just like when we learned about functions, we can actually provide default parameters here. So we'll define a default parameter of 1. So that's a default value for the radius. And I will say self dot radius is equal to the radius that was passed in. And then I'm going to make a method here. So now we have our method. And we'll say this method is called get circumference. And what this does is it has in self, so it can reference the particular instance of the object. And it's going to, no, I'm returning it. I'm not printing it out. I'm going to return the actual circumference of the circle. So if you do a little bit of math, you know that circumference of a circle is the radius of that circle times pi times 2. So 2 pi r is the circumference of a circle. I run that, and let's create an instance of the circle. So I can say my circle is equal to circle. And then when I call my circle here and hit dot, tab, I can have get circumference, and I can actually see here I have pi, and here I have radius. And I actually spelled circumference wrong, but let's actually fix that real quick. Circumference. Now I rerun this, rerun circle, hit tab, and now I see get circumference, pi, and radius. So let's call pi, see what happens. We get back 3.14, makes sense, it's a class object attribute. It's an attribute that's going to be the same regardless of what instance of the class. Then I'm going to say my circle dot, and let's call it radius, and it's 1. So why is radius 1? Because that was the default value I provided up here. What I could have done is provided another value for radius. Let's provide maybe 30 for radius here. And then it would have just overwritten default values. So then when I call radius again, after rerunning that assignment, I have 30. So you can have a default value here, and you can always overwrite it. Okay, so now let's see what happens when we call this method. We'll call my circle, and I will get the circumference, open close parentheses, run that, and it returns back the circumference. In this case, 188.4. Now those are the basics of methods, and I want to come back up here and show you a couple more things that you may consider when working with object-oriented programming. One thing to consider is that if you have an attribute, it doesn't necessarily have to be defined from a particular parameter call. So for example, I can create an attribute for the area. So a circle can have an area attribute, and I can say self.area is equal to the radius that's passed in times the radius that's passed in times pi. So pi r squared is the area of a circle. So I can say self.pi. And now I will have an area when I define the circle. So I can say circle 30, my circle.pi, radius, and if I call my circle here and ask for the area back, I get back the area of that circle. The last thing I want to point out is because this is a class object attribute, I actually have two ways of calling it. I could say self.pi because self references a particular instance of this object, or something people sometimes like to do is actually say circle.pi if it's a class object attribute. So if it's a class object attribute, you can reference it in this manner, which is the name of the class and then the attribute, because you know this is going to be the same regardless of the instance of the class. So you may see it this way as well. And sometimes programmers prefer it this way because if you're reading someone else's code, it's very easy to see down the line, oh, this is a reference to a class object attribute. So it may be obvious here because our class is smaller, but you can imagine if we had hundreds of methods, instead of saying self.pi here, it might be nice to say circle.pi. That way when you're on line 101 or whatever it is, you can see here, oh, they're referencing a class object attribute at the very top of this class. So you run this and you'll get back all the same results. It'll all work exactly the same. So again, you can use self.pi, or to really make it clear that it's a class object attribute, the name of the class dot the attribute name. All right, that's it for the basics of methods. Coming up next, we're going to discuss inheritance and polymorphism. We'll see you at the next lecture.